So now we have some notes on the quadratic equation section of your formula chart. So again, first things first, as soon as you get your test, you can take out this formula chart and box in any letters that are going to get substituted with numbers. I really like this especially if you have high test anxiety, because it clears things up quite a bit. It narrows your focus. So here you would replace A, H, and K. That would be transformations. And oftentimes we don't realize that this vertex form is our transformations. So note there, because this is really, really, really important. In our quadratic formula, this is where we often mess up, is with any time you have a negative b. So definitely box that in. Keep in mind, all of these boxes are going to get replaced with parentheses whenever you go to plug them into your calculator. Axis of symmetry we don't really use too often because it's simply where it crosses the x. And you can pretty much graph anything in your calculator as long as the y is by itself. And then you can just see where it crosses the x-axis. Playing with your window, zooming in and out, that kind of thing. So first on standard form. The big thing is knowing what C is. So hopefully as soon as I say what is C, some of you guys know C is the y-intercept. You can usually eliminate answer choices just knowing that this is the y-intercept. It's the same as in slope-intercept, where this last number here is the y-intercept. Well, this last number here is the y-intercept, as long as the y is by itself. So in vertex form, you have A, H, and K. You just got to know what those affect. So A affects reflections, stretches, and compressions. Just knowing the placement can do a world of good with eliminating answer choices. H is pretty simple because it's horizontal and it starts with an H. That can be a shift left or right, which makes sense because horizontal only goes left and right. K is a vertical shift, and that affects up and down. So as long as you know these three pieces, what they affect and where they're at, you should be able to eliminate at least half the answer choices on a transformations problem. So the key with quadratic formula is to put parentheses where the boxes are, so in place of the boxes. Because when you have a negative b, if it's not in parentheses, you're not going to get the right answer. So that leads us to the number one mistake. Every time you have a negative b, it's got to be in parentheses. That's how you avoid the mistake, is putting it in parentheses. So one more note would be that if you have f of x, g of x, h of x, z of x, whatever, all of those are the same thing as y. You could honestly cross them out and put a y above them, and it wouldn't make a difference. The only kicker is whatever's inside the parentheses is your x. So for instance, if you have f of 5, that still equals y. This whole thing is y. It's the x that's 5, which means we have a very specific y. So this piece is really important to remember. Whatever is inside the parentheses in place of the x, I always prompt my kiddos by just saying f of what? X. Well, if there's a 5 there now, then the x is 5. That's the basics of function notation. Then you have what a stretch, compression, reflection, what those all look like. So right here, if this parabola gets skinnier, that's a stretch. We like to say big A. A bit like something more than 1. So 3 over 2, for instance, that's 1.5. So that would create a stretch. If you have a small a use a different color here. If you have a small a, that is a compression. So I think of this like chest compressions in CPR. When you're pushing down for chest compressions, it is pushing the lungs outward, not pulling them up. So a compression is pushing downward. Knowing what it looks like helps a little bit. And then you have something that's upside down. So this would be a negative A. That's what causes a reflection.